Hello students, welcome to our program for General Second Certificate. Now we are going to study some exercise and problems on dynamic as final revision. As number 1 we say, two bodies of masses m1 and m2 gram, m1 greater than m2 are connected with a string passing over a small pulley. They are on the same height from the ground as beginning motion. After 1 second, the vertical distance between the two bodies is 20 centimeters. Now, find M1 to M2. As solution we say, since M1 greater than M2, therefore, the equations of motions becomes M1G minus T equal M1A as first equation, and T minus M2G equal M2A as second equation. From 1 and 2, we get that G as common factor, M1 minus M2 equal M1 plus M2 times A, and the expression A is given by G times M1 minus M2, all of them divided by M1 plus M2 as third equation. Now, after 1 second, each body moves. 20 divided 2 equal 10 centimeter, and since S equal UT plus half AT square, by substituting we get that 10 equal 0 times 1 plus half times acceleration A times 1 power 2, or the acceleration A equal 20 centimeter per second square. Now, from the equation 3 we get that 20 divided by 980 equal M1 minus M2 over M1 plus M2, or 1 over 49 equal M1 minus M2 over M1 plus M2, or 49 M1 minus 49 M2 equal M1 plus M2, and 48 M1 equal 50 M2. Now, the ratio M1 over M2 equal 50 divided by 48, which is equal to 25 divided 24, or we can say M1 to M2 is equal to 25 to 24. Let us see another one. A body of mass 2 gram moved on a plane under the effect of the force F, 8I plus 4J. The position vector R is given by A t square plus 5I plus bt square plus tj, where R is measured in centimeter and t in second. Now, find the value of A and B, then calculate the work done by the force F in the interval from t equal 0 till t equal 5. Now, as solution we say, the displacement vector is given by S equal R minus R naught, or S equal AT square I plus BT plus TJ as first equation. Also, the velocity vector is given by V equal derivative of S or ds dt, which is equal to 2ATI plus 2BT plus 1j. And the acceleration vector A is given by dv dt or 2ai plus 2bj. Now, since the force F equal m times A, by substituting we get that 8i plus 4j equal 2 times 2ai plus 2bj tends to 8 equal 4a, and the value of a equal 2. Also, 4 equal 4b tends to b equal 1. Now, from the equation 1, we say the displacement vector S equal 2 t square I plus t square plus tj, or, and the work done F dot S, where 8 and 4 dot 2t square and t square plus t. We get that 16t square plus 4t square plus 4t, which is equal to 20t square plus 4t. So, at t equals 0, the work or W1 equals 0. And at t equal 5, as W2 equal 20 times 5 power 2 plus 4 times 5, which is equal to 520. Therefore, we say the work done from t equals 0 to t equal 5 is given by W equal W2 minus W1, or 520 minus 0, which is equal to 520 erg. Let us see another one. A body of mass 100 gram is placed on a plane inclined on a horizontal at an angle of measure 30 degree. It's connected by light string passing over a smooth small pulley at the top of the plane to be tied at its other end, a body of mass 150 gram. Now, if the coefficient of friction is 1 over root 3, find the time which passes before the first body moves a distance 200 centimeter on the plane. Also, obtain its speed. As solution, we say that since R equal 100 G cosine 30, or equal 50 root 3 G. Now, the equation of motion are given by 150 G minus T equal 150 A. Also, T minus mu R minus 100 G sine 30 equal 100 A. By adding, we get that 150 minus mu R minus 50 G equal to 150 A, or 150 G minus 1 over root 3 times 50 root 3 G minus 50 G equal to 150 A. As simplest form, 980 as G times 150 minus 50 minus 50. All of them equal to 150 A, and we get the value of the acceleration A equal 196 centimeter per second square. So, since S equal ut plus half at square, by substituting we get that 200 equal 0 times t plus half times 196 times t square, and we get the value of t square equal 200 divided by 98 or 100 divided 49. Now, the time which passes before the first body moves to 100 meter, t equal 10 over 7 second. And now, since v square equal u square plus 2as, by substituting we get that v square equal 0 square plus 2 times 196 times 200, and we get the velocity v equal 280 centimeter per second. A mass of car is 3 tons ascending a road inclined to horizontal at an angle of sine 1 over 10 against the resistance 40 kilogram weight per ton with uniform velocity. If the car ascending to 20 meter. Now, find the work done from each of the following. Number 1, the weight of the car. Number 2, the resistance of the road. Number 3, the force of the engine. And the last one, number 4, the resultant of the forces. As solution, we say that the work done by the weight of the car is given by W equal minus W sine theta times S. So it's equal minus 300 times 0.1 times distance 20, which is equal minus 6,000 kilogram weight meter. As second required, the work done by the resistance of the road, W equal minus 40 times 3 times 20, or 2,400 kilogram weight meter. As third required, F minus W sine theta minus R equal MA. Cancel MA because it is uniform velocity. Now, F equal W sine theta plus R, which is equal to 3,000 times 0.1 plus 40 times 3 equal 420 kilogram weight. And the work done by the force of the engine, W equal 420 times 20 equal 8,400 kilogram weight meter. Last one, the work done by the resultant of the forces acting on the car equal 0 because the motion is uniform motion. Let us see another one. A track of mass 6 tons is ascending a road inclined to horizontal with an angle of inclination of sine 1 over 100 with maximum velocity of 63 kilometers per hour. Now, find the force of the engine and the magnitude of the resistance on the road for each ton of the track, knowing that the engine power is equal to 210 horses. Now, the velocity V equal 63 times 5 over 18, which is equal to 17.5 meter per second. And the power of the engine, P equal F times V, or 210 times 75 equal F times 17.5. Therefore, the force of the engine, F F equal 900 kilogram weight. Also, the equation of motion is given by F minus R minus mg sine theta equal ma, and 900 minus R minus 6 times 1000 times 1 over 100 equals 0. Therefore, the resistance of the rod R equal 900 minus 60 equal 840 kilogram weight. And the resistance per each ton is equal to 840 divided 6 equal 140 kilogram weight. Let us see another one. A car of mass 1800 kilogram and of power 90 horse, ascending a rod inclined to the horizontal at an angle of sine 5 over 36 with uniform velocity 54 kilometer per hour. Now, find the magnitude of the resistance to its motion and calculate the maximum velocity with which the car moves on horizontal ground, ascending horizontal ground, amusing that the resistance doesn't change. Now, as solution we say velocity V equal 54 times 5 over 18 equal 15 meter per second, and the power P equal F times V, or 90 times 75 equal F times 15. So the force F equal 450 kilogram weight. And the equation of motion is given by F equal R plus mg sine theta, or 450 equal R plus 1800 times 5 over 36, and we get that R equal 200 kilogram weight. As second required on horizontal ground, we say F dash equal R equal 200 kilogram weight, and the power P equal F dash times V dash, or 90 times 75 equal 200 times V dash, and the velocity as maximum we get that V dash equal 135 divided by 4 meter per second, or 135 divided 4 times 18 over 5, which is equal to 121.5 kilometer per hour. Let us see another one. A car of mass 6 tons ascending in the line of the great slope of the plane inclined to the horizontal and an angle sine 1 over 100. Now, if the resistance of the air and friction is equal 20 kilogram weight per ton of mass, and the maximum velocity with which the car moves is 36 kilometer per hour. Now, calculate the power of the engine of the car in horses. Then calculate the maximum velocity with which the car descending the plane, amusing that each of the power of the car and resistance of the plane doesn't change. As solution we say, first, in the case of ascending the velocity maximum, we say V equal 36 times 5 over 18 equal 10 meter per second. And the equation of motion is given by F minus R minus mg sine theta equals 0, or F equal R plus mg sine theta. So F equal 20 times 6 minus 6 times 1000 times 1 over 100, and the value of F equal 180 kilogram weight. Now, since the power of the car P equal F times V equal 180 times 10 over 75 equal 24 horses. As second case, in the case of descending, the equation of motion is given by F dash plus mg sine theta minus R equal ma, or 0, because the acceleration equals 0. So F dash equal R minus mg sine theta by substituting 120 minus 6 times 1000 times 1 over 100, or equal 60 kilogram weight. And now, since the power P equal F dash times V dash, or 24 times 75 equal 60 times V dash, and we get that V dash equal 30 meter per second, or 30 times 18 over 5, which is equal to 108 kilometer per hour. A particle moves such that its displacement vector S is given as a function of time t by the relation S equal t square plus 2t I plus 2tj, where S is measured in meters and t in second. Now, if the kinetic energy of this particle at t equal 1 is equal to 0.4 joule, calculate the mass of the particle. As solution, we say, since displacement vector S equal t square plus 2t I plus 2tj, then the velocity vector V equal ds dt equal 2t plus 2i plus 2j, and at t equal 1 we get that the velocity v equal 2 times 1 plus 2i plus 2j, or v equal 4i plus 2j, and the norm of v equal square root of 4 square plus 2 square, which gives square root of 20 meter per second. Now, v square equal 20 meter per second, and since kinetic energy T equal half mv square, so 0.4 equal half m times 20, and we get that the value of m equal 0.4 divided 10, or equal 0.04 kilogram, or the mass equal m equal 40 gram only. Another one, a smooth sphere of mass 1 over 5 kilogram moving in a straight line with velocity of 9 meter per second on a smooth horizontal plane collides with another smooth sphere of mass 2/5 kilogram at rest. Now, if the two spheres form one body after impact, find number 1, the common velocity just after impact. Number 2, the loss in kinetic energy in joule due to the impact. As solution, we say, from the given, we get that m1 v1 plus m2 v2 equal m1 plus m2 v as common velocity, or 1/5 times 9 plus 2/5 times 0 equal 1/5 plus 2/5 times v, and we get that the value of v equals 3 meter per second. As second required, we say the kinetic energy before collision, or TB, equal half m1 v1 square plus half m2 v2 square, or 1/2 times 1/5 times 9 power 2 plus 0, which is equal to 8.1 joule. And the kinetic energy after collision, TA, equal 1/2 times 3/5 times 3 power 2, which is equal to 2.7 joule. Now, the lost kinetic energy, TA minus TB, equal 8.1 minus 2.7 equal 5.4 joule. Let us see another one. A horizontal force acted on a body at rest placed on horizontal plane. The body moved from certain time until its momentum reaches to 157,509 seconds, and its kinetic energy was equal to 16,875 gram weight, centimeter. That instant, the force stopped acting on the body, after which the body traveled distance 21 meters before came to rest. Now, find the mass of the body and the resistance of the plane, amusing that it's constant. As solution, we say that since the momentum mv equal 157,500 as first equation, and the kinetic energy T equal half mv square, which is equal 16,875 times 980 as second equation. Now, from the two equations, by division, we get that half mv square divided mv equal 16,875 times 980 divided by 157,500, and we get that V equal 200 centimeter per second. And from the first equation, we get that M times 210 equal 157,500, or M equal 750 gram. As second required, since V square equal U square plus 2AS, by substituting we get that 0 square equal 210 plus 2 times acceleration A times 2100, or A equal minus 10.5 meter per second. And the equation of motion is given by minus R equal MA. So minus R equal 750 times minus 10.5, which gives R equal 7,875 dyne. With my best wishes for all of you, thank you and goodbye.